Okay. So at a basic level, managing containers is pretty easy, but when I start running them in a real environment, you get a lot of them. And that's typical when you talk about a microservices architecture. It's not one container per application, it's one container per component. And that's not going to work if we don't have something to organize it for us. So this is where Kubernetes come in. Kubernetes is one of many container orchestration systems. We're going to focus on that today in the presentation. But what container orchestration allows us to do is allows us to surround the resources that are needed by containers in order to run them more effectively in a data center environment. So Kubernetes came from a system that was built originally at Google, and it had some time at Google to go through a lot of incubation. So it has many features that, unlike some open source projects which come out into the world pretty early, many of the features that were needed for the full system to work as a container orchestration environment were already baked in when it came into the open source world. And since it's come into open source, a large number of organizations have continued to innovate and add capabilities to this base set of functionality. I think the key thing that we'd want to point out here about Kubernetes is that it's based upon managing resources, and it manages resources with a declarative model. What you can do with a declarative model is you can make a statement about what I want the data center environment to look like in terms of resources, and then Kubernetes system will make it happen. So we make these statements through an API system. And here what we have is a database, which is based on etcd, which is a highly available database system. And a client will make a request for something that's needed within the environment. So for example, I might need to set up some storage for a container. So I make a request for the storage, and then I make a request to start a container mapping that storage. Each one of these requests that go to the API server are monitored by a collection of watchers, and the watchers then run controllers to orchestrate and deploy and manage the container environment. And so one of the great features that we have here, and this is sort of a high-level cartoon on the right-hand side that you see, is that we can do some things at a much higher level than just running containers at a CLI kind of environment. For example, we can accomplish automating the scheduling of resources with the environment. We'll have a capability to do what's called zero downtime deployment. And what that means is when I'm going from version 1 to version 2 of an application, when I do a kubectl rollout, what I'll do is I will add pods. A pod is the scalable unit, the small scalable unit. A pod can have one or more containers. I will add pods at the version 2 of the application, and I'm balancing traffic between version 1 and version 2 of the application. Eventually, as I've completed that, I'll switch over all the traffic to the second version of the application. And this is a very built-in natural way to get zero downtime for deployments. Also, the Kubernetes system, the API server, can be deployed in a HA configuration with, one is single, not HA, but you can have 3 managers, 3 of those API servers, all talking to the same, consistent image of etcd. Then that will allow you to have high availability at the management of the cluster. Additionally, on the nodes, again, are running the containers and the pods. If I have a container crash, then that's a change to the state of the system. And the Kubernetes system, since it's a declarative model, will take actions through the controllers to bring up other resources to match what has failed.
Here is a more detailed diagram of Red Hat OpenShift, which provides Kubernetes and a number of other services around Kubernetes so that it's suitable for enterprise deployments. In addition to providing the master with the APIs and resources for Kubernetes, OpenShift includes built-in developer extensions and abstractions to make it easier to be able to deploy applications. It also includes an internal registry that can be used to store your Docker images, and it includes some useful dashboards and built-in logging and monitoring capabilities for administrators.